Hello class, today we're going to look at the first lesson in chapter 10. So chapter 10 is all about quadratic functions. We're going to start by graphing those quadratic functions. So 10.1 is called graphing parabolas. Let's get started. We have two learning targets today. We are going to first discover how adding a constant to the parent function y equals x squared, that's x squared by the way, affects the graph of a function. And second, we're going to use the zeros of a quadratic function to find the vertex of the graph of the function. All right? Lots of vocab in this section, so make sure you go through and review those vocab words. Let's get started. So first, the definition of a quadratic function. We define a quadratic function as a function of the form y is equal to ax squared plus bx plus c, where a, b, and c are all real numbers, and a cannot be 0, because if a was 0, we would no longer have a quadratic function, we would just have simply a linear function. Alright? So we need to make sure we have that ax squared. Alright? Now, the shape that this function makes is called a parabola. Looks something like this. Alright? This would be the graph of the parent function of quadratic functions. Y is equal to x squared. It's the most simple quadratic function there is. What I'm about to show you is we're able to take this parabola and move it all over the coordinate plane. We can even flip it, make it more narrow, make it more wide. We can do all sorts of things with that. Let's go ahead and get started with that. So, like I said, we're able to move it around. Instead of just looking at this, how about we go ahead and use Desmos to see what's actually happening here. So, I went ahead and I graphed y is equal to x squared already. Okay? Again, this is the parent function. Let's go ahead and write that down. So for quadratic functions, our parent function, which again is just the most simple form of whatever function we're looking at, is y is equal to x squared. Alright, that's our parent function. That's what we call the parent function. What we're going to do next is we're going to use Desmos to see how we can move around that y is equal to x squared. So the first I want to show you, so again, I went ahead and I graphed y is equal to x squared. Alright, let's say we took that y is equal to x squared and we added some number, like this. As you can see, it moved my graph up. What if we subtracted some number here? As you can see, it moves my graph down. So the first thing I want to write, when we go back to our notes here, I'm going to be switching back and forth a lot, so please be patient, is if we take that parent function, y is equal to x squared, and we add some number a, that causes our parent function to go up a units. Let's get rid of that arrow, that might be confusing. And the other one you just saw is if we took that parent function and we subtract some number a, we go down that many units. So that's our first translation we're going to look at. Next, let's go back to our Desmos. I'm going to change how this looks a little bit, okay? So let's go ahead and get rid of this for now. Instead of just having x squared, I'm going to put that x in parentheses. There we go. And the same thing with this second one. We're going to put that x in parentheses. Alright, so it still makes our quadratic function our parent function. But what if I add or subtract within that parenthesis? Okay? So let's say I do x minus some number. Let's say x minus 4. As you can see, that moved my function 4 units to the right. What if I add some number in there? So plus 3. As you can see, that moves my function to the left. So the next translation we want to put in our notes is if we have a set of parentheses like this, so y is equal to x squared like that, and if we add some number a within those parentheses, it's going to move my function to the left that many units. And what you also saw is if I have those parentheses again, and I subtract some number a, that's going to move my graph to the right a units. So these are my horizontal and my vertical translations, all right? Now, here's the thing. We're going to put all of these together in just a minute into something we call vertex form. But before we do that, we got to look at two more things. So, let's keep going. Again, we're going to say the parent function is y is equal to x squared. What happens if I take that x squared and I multiply it by some number a? Well, let's see. Let's go back to decimals. So we go back to our decimals, right? Okay, and we're going to say, all right, y is equal to, we can just leave it at x in parentheses again. So x squared. What happens if I multiply this by, let's say, 3? As you can see, my parabola got much more narrow. Okay? What if I multiply it by, I don't know, something like 1/3 instead? As you can see, my parabola got much more wide. So, we can generalize this for our notes as follows. If the absolute value of a, notice I used absolute value. We'll come back to why I used absolute value in just a moment. If the absolute value of a is greater than 1, the parabola will get more narrow. We also call this a vertical stretch. Vertical stretch. It's like it takes the parabola and it's stretching it out. So instead of being this wide, it gets stretched out and becomes this wide. More narrow. But also we saw if we multiply by some number a, and the absolute value of that a is less than 1, it becomes more wide. Okay? This is called a vertical compression. Alright? All you need to remember for the purposes of this class is Algebra 1, that if the absolute value of a is greater than 1, your parabola becomes more narrow. And if the absolute value of a is less than 1, your graph becomes more wide. That's all you need to remember for this. I'm not going to ask you about vertical stretch or compression yet. All right? And the last thing I want to show you, one more thing, all right? If a is a negative number, well, let's see what happens. If I go ahead and make this a negative number, so we'll keep it 1/3. Let's make it negative 1/3. Let's see what happens. What it does is it flips our graph, okay? Or reflects it. So here's what I want you to write. If a is a negative number, we'll just keep it simple for now. We'll say flip. Flip the parabola. Okay? So that's why I said if the absolute value. Because even if a is negative, but the absolute value of a is still greater than 1, so let's say it's like a -2, it'll still flip and then just become more narrow. So this rule still applies. It'll just, if this is a -2 for instance, it'll just flip it along with it. Great. Now here's the thing. we've seen all of these changes that can take place, all right? If we add or subtract outside of parentheses, add or subtract within parentheses, multiply by some number in front. What we're going to do is we're going to take all those changes and put it into one spot, in which we can call vertex form. Vertex form of a quadratic function is y is equal to a times the quantity x minus h squared plus k. Y is equal to a times the quantity x minus h squared plus k. And what's nice about this is this tells us a really helpful piece of information. It tells us our vertex. Our vertex of a quadratic function that's in vertex form can be found at h, k. And we can also say the axis of symmetry. Is that x equals h. Let's talk about what each one of those are. Let's talk about what each one of those are. So let's go back to Desmos. Okay? Let's go back to Desmos and let's come up with some function. I'm just going to make it up off the top of my head. So let's go ahead and hide the red one here. And we're going to make the function y is equal to 2 times the quantity x minus 3 squared plus, I don't know, 4. And there's my parabola. And there's my parabola. Now here's the thing. This is in vertex form. That is in vertex form. That is a function in vertex form. Let me write it a little bigger so I think you can't see it on the camera here. So the function I use is y is equal to 2 times the quantity x minus 3 squared plus 4. Now what you should see is this looks very similar to that vertex form I just told you about. A times the quantity x minus h squared plus k. So we can pick out some very important information. Like we just wrote down in our notes, we know that the vertex is at hk, or in the case of this function, my vertex, my h value would be 3, and my k value would be 4. So any function that's in vertex form, we can pull the vertex out just by looking at h and k. Another thing we can look at is this a value, which tells us the shape of the parabola. Is it going to be more narrow, more wide? Is it going to be flipped upside down or right side up? So looking at this vertex form, I can tell you that the vertex is at 3, 4, which, quick little side note by the way, I know that h looks like a negative 3, but h is a liar. Notice how in vertex form we have x minus h, so x minus 3 means our vertex is at a positive 3. And then our k always tells the truth, so k is 4. And you'll notice here that the vertex of the graph that they gave me is at 3, 4. Alright? And then I can look at the a value and I can say, alright, it's a positive 2, which means I will open up, and since it's 2, since it's greater than 1, it'll be a little bit more narrow than our normal parent function. So that's vertex form. Here's how I'm going to ask you to use it, at least for now. Let's go back to our notes. Let's say I ask you to sketch the graph of this function. Well, you should see that this function is in vertex form. Okay? Y is equal to a times the quantity x minus h squared plus k. Okay? That is in vertex form. So first we can steal the vertex. The vertex is at hk. My h value is a 1. It looks like negative 1, but h is a liar. and my k value is 2. So my vertex is at 1, 2, right here. I can also tell, looking at this function in vertex form, since my a value, it doesn't even look like there's one, right? But there's actually a hidden 1 there. Since that's positive, I know my parabola is going to open up. So just like this. And that's all I'm going to need you to do for now. I just need you to be able to find the vertex and then sketch the parabola, whether it opens up or down. That's all I'm going to look for. Later in the chapter, we will get more specific with exactly how the shape should look. But for now, when we're just sketching, correct vertex and whether or not it opens up or down. Okay? The other thing that I mentioned in the notes over there was the axis of symmetry, which we like to abbreviate AOS. The axis of symmetry happens at x equals h. Well, h in this case was 1. Okay? Here's what the axis of symmetry does. This is actually the equation of a line. And anytime we have x equals some number, it is a vertical line. So this is a vertical line at 1. Let's go ahead and draw that. So vertical line at x equals 1 will look something like this. There we go. What you should see, and unfortunately my parabola is kind of off kilter, but what you should see is that this axis of symmetry cuts my parabola directly in half. That's the whole point of the axis of symmetry. It just means that my parabola is symmetric on either side of that axis of symmetry. This is another thing we will use later on in the chapter to really draw our parabolas better. All right? So for a problem that looks like this, give me the vertex, plot the vertex, tell me whether or not the parabola opens up or down, plot it that way, and last, identify the axis of symmetry, which is the vertical line that cuts our parabola in half. And that's all I'm going to need you to do when you're sketching a parabola for now. Now, let's say we have something like this. Let's say I want to find the zeros, okay? I want to find the vertex, but I'm not in vertex form, all right? When we're in vertex form, it's easy enough, you just identify h and k and that's your vertex. But what if I want to find the vertex, but I'm not in vertex form? Say this function right here, y is equal to x squared minus 8x plus 7. How can I find the vertex of that if I'm not in vertex form? Well, in section 10.3, which we'll be doing soon, we're actually going to take a function that's in a quadratic function that's in standard form, and we're going to rewrite it into vertex form. But for now, I have another way to show you. So let's say this function here, okay? Let's say we have y is equal to x squared minus 6x plus 5. And I want the vertex of this function. Here's what we need to do. We need to first find the zeros. Now, luckily we learned that in section 9.8 in the last chapter. We set this equal to 0, and now we can factor and solve. Factors of 5 that add to negative 6 would be negative 5 and negative 1. Set each factor equal to 0 and solve. So one of my zeros is 5. My other 0 is 1. Now here's the thing. When we graph a parabola, so let's go ahead and look at the graph of this parabola, x squared minus 6x plus 5. Whoops, that's not what I want to do. I would edit that out of the video, but I don't know how. So here's what I'll do. I'm going to break out of this. Go back to our Desmos. Let's go ahead and graph that function we were just looking at. So x squared minus 6x plus 5. And as you can see, we just found the zeros, and those zeros happen to be 5 and 1, like we just found. Now here's the thing. Parabolas are symmetric, okay? And it's symmetric based on the axis of symmetry, which happens to go through the vertex. So what that tells me is the vertex is right in the middle of my two zeros. So therefore, I can find the x value of my vertex by adding my two zeros together and dividing by 2. Basically finding the average of those two x values. Let's do that. So the x value of my vertex, which we'll call h, we take our two zeros, 1 and 5, we add them together and we divide by 2. So we end up with 6 over 2. We end up with the h value of our vertex is at 3, which as you can see here is correct. To find the k value, we plug this in to our function. So we do y is equal to x squared minus 6x plus 5. I just found my x value, I want it to be 3. So y is equal to 9 minus 18 plus 5, or y is equal to negative 4. As you can see, that's where my vertex is. So if we are in standard form, if we want to find the vertex, find your zeros, add them together, divide by 2. That'll give you the x value of your vertex. Then to find the y value of your vertex, plug that into our function. We will be doing much more practice with that. I'll probably put up another example onto YouTube as well, so be on the lookout for that. So, that is section 1 in chapter 10. What we just learned, we learned how to discover adding a constant to the parent function affects the graph of a function. Okay, if we added it on the end, that moved it up or down. If we added it within those parentheses, move it to the left or the right. And then we use the zeros of a quadratic function to find the vertex of the graph of the function. Those are the two main skills you need from this chapter. Go ahead and give your homework a try. Have a great day.